This is Joseph from Brainstorm Academy. I'm an IGCSE Chemistry specialist, and today we will be looking at Cambridge IGCSE for Paper 4 Theory Extended, and this is variant 2 0620 from May-June 2025. Question 1. Using numbers only, state the percentage of nitrogen in clean dry air, that's 78%. The typical operating temperature of contact process in degrees Celsius, there will be 450 degrees Celsius. The number of metals in period 3 of the period table, so there will be sodium, magnesium, and aluminium. So there's a total of 3 metals. Number of halogens which are gases at room temperature and pressure, there will be fluorine and chlorine, so 2. The typical temperature for the fermentation of glucose. Okay, fermentation of aqueous glucose in degrees Celsius. So based on the syllabus, it's 25 to 35 degrees Celsius. So you can write any values that is in between. You can write 25, you can write 30, you can write 35. The number of unbranched structural isomers of C4H8, which decolorizes aqueous bromine. Now, what are structural isomers? Substances with the same molecular formula but different structural formula. So there are 2 options here. It's either build 1-in, which is having your carbon-carbon double bond on the first carbon and the second carbon, or build 2-in. These are the unbranched isomers. So it's CH3, CH double bond, CH, CH3. There is no such thing as a build 3-in, okay, because we look at the substance in a 3-dimension manner. So build 3-in and build 4-in doesn't exist. So the answer is 2, all right, 2 possibilities which can decolorize aqueous bromine by addition of bromine reaction. So this is more like, you also need to know this. This is what we call 1,2 dibromoethane. And then this one will form 2,3 dibromoethane. Okay, and this compound is colorless. That's why it decolorizes aqueous bromine. Okay, next, number of covalent bonds in a molecule of ethanol. So first we can draw ethanol, and we can just count the number of lines, honestly. So this is how you draw ethanol. So there's 4 lines, and here 1, 2, 3, 4 lines. So in total there are 8 covalent bonds. And last, the number of carbon atoms in one molecule of propyl butanoate. There are 2 choices here. You can either draw the whole structure or simply just look at the name. Prop means 3 carbon, but means 4 carbon. So in total, 7 carbon. Okay, so that's for question 1. Let's look at question 2. This question is about covalent compounds. State what is meant by a covalent bond. Now, for IG chemistry, we define it as 2 atoms sharing pair of electrons. So example, let's say chlorine and chlorine, they share pair of electrons. That's all. Next question. Chlorine 1 oxide is a molecule, simple molecule with covalent bonds. State what is meant by the 1 in the name chlorine 1 oxide. So it is the oxidation number. And you have to specify which chemical, which is chlorine. Okay, and also what does it mean? It means that it is +1. So the common mistake students make is that they didn't address the meaning, they didn't address which element, and they didn't address the oxidation number value, and they tend to overlook the symbols. So make sure you take note of that. Next, complete a dot and cross diagram in a figure of a molecule of chlorine 1 oxide. Show outer electrons only. Now for this one, I have 2 methods. Number 1, Method one is simply using your periodic table and kind of ask yourself like, how many do they need to get a full outer shell? So first of all, chlorine is a group 7 element. It needs one more to get a full outer shell. So it will also share one in exchange because covalent bonds are fair. If one element shares one electron, the other will also do the same. Then our oxygen here, before we talk about oxygen, there's also leftover. Okay, leftover, chlorine leftover after 7. Okay, sharing 1, leftover will be 6. For our oxygen here, which is a group 6 element, same idea. It will need 2 to get a full outer shell. It will share 2 in exchange. So leftover 4. So by applying this concept, we know chlorine there will be 6 non-bonding electrons. And they will share 1 for the covalent bond, each of them. And our oxygen will contribute 2 for sharing, so 1 for each chlorine, leaving behind only 4 non-bonding electrons. Now, the other method is more like what we call Lewis diagram, or should I say it's somewhat like your organic chemistry where you use lines to represent the covalent bonds. Okay, of course, this is not technically an organic molecule, but the concepts are really similar. So chlorine, which is a group 7 element, likes to form 1 line. Oxygen, 2 lines. Right? Lewis diagram. So how do you know this? You can actually look back at your organic chemistry where oxygen likes to form 2 lines and then chlorine likes to form 1 line. So after this, you also have to show the non-bonding. So chlorine left over 6, oxygen left over 4. So you can also use this and translate it back to this diagram. So there are 2 methods, or you can combine both methods, whichever that you feel more comfortable with, as long as you're able to show the non-bonding electrons as well as the bonding electrons. So chlorine non-bonding 1 mark, oxygen non-bonding 1 mark, and the bonding electrons 1 mark. Next, explain in terms of structure and bonding. Why Cl2O boils at a low temperature and does not thermally decompose into its constituent elements Cl2 and O2? Now, first, this is a simple covalent molecule, meaning the structure is a simple molecular lattice. So if we look at Cl2O in its lattice structure, we see that this Cl2O, these molecules are weakly attracted to each other via this weak intermolecular bonding, or what we call weak intermolecular forces. So, right, so the reason why it boils at a low temperature is because of the weak intermolecular forces between the Cl2O molecules in its simple molecular lattice. Okay, that's why it boils at a low temperature. We do not break the covalent bonds, by the way. We only break this for boiling. Okay, then why does it not thermally decompose? Well, as I told you earlier, the strong covalent bonds. So the reason why it doesn't, I'm going to write TD, thermally decompose, is because, okay, of course in the exam, write in full, is the fact that there are strong covalent bonds between Cl and O atoms in each Cl2O. So basically, it's a misconception to a lot of students. A lot of students thought that covalent bonds are weak. Actually, it's very false. Covalent bonds are strong. Okay, it's very strong. It's not easy to break them. Okay, so based on the mark scheme, the first mark is about the boiling only breaks the weak intermolecular forces. That's the first mark between the molecules. And then for thermal decomposition, the strong covalent bonds, between the Cl and O atoms are broken during thermal decomposition. So that's why at low temperature, it doesn't thermally decompose. And the third mark is about this force is weak and these bonds are strong. Okay, so let's move on. Give two reasons why liquid Cl2O is a poor conductor of electricity. Well, in fact, you can see from the diagram, because there's no free moving electrons. Like for example, in metals or graphite, which allows them to conduct electricity. And also it has no free moving ions, like in ionic compounds in their molten or aqueous state. Next, carbon and silicon oxide both exist as giant covalent structures. Name a giant covalent structure of carbon which conducts electricity. That will be graphite, as mentioned earlier. Next, identify the particles responsible for the conduction of electricity in its covalent structure of carbon. As mentioned earlier, graphite is because of the free moving electrons. Next, silicon oxide contains silicon atoms and oxygen atoms. So the figure 2.2 shows part of the giant covalent structure of silicon oxide. Complete the diagram in the figure by adding symbol for each of the 9 atoms shown. Now, silicon is a group 4 element. It will form 4 lines. Oxygen is a group 6 element. It will only form 2 lines. So using this logic, we can see that this is silicon, 4 lines, and these are oxygen, only surrounded by 2 lines, and silicon. By the way, lines meaning covalent bonding. Okay, so that's all, and that will give you 2 marks basically. Let's move on. This question is about electrolysis. Complete the definition of electrolysis by filling in the missing words. So electrolysis refers to the decomposition of ionic compounds when molten or aqueous. The molten or aqueous state by the passage of electric current. Next, electrolysis of aqueous copper 2 sulfate is carried out using the apparatus shown. The electrodes are made of platinum. State whether the mass of the cathode increases, decreases, or remain the same when platinum electrodes are used. Okay, platinum electrodes are inert electrodes. That means it will not affect the electrolysis process directly. So our copper 2 sulfate here, okay, that's coming from a solute, and then it's an aqueous solution. That means there's water, which contributes to hydrogen and hydroxide ions. Now, at the cathode, reduction happens. And the cathode is the negative terminal. It will attract the positive ion. So it's either copper 2 or hydrogen that gets discharged. Now, the answer is copper 2, because if you know your theory well, copper has a lower reactivity than hydrogen, or some schools will prefer to call it this way, which is copper is easier to get discharged compared to hydrogen. So therefore, it's not hydrogen that is formed, instead copper 2 is formed. So since copper is deposited around the cathode, the negative terminal, that means this mass will get larger. Next, describe the change in appearance, if any, of the electrolyte when platinum electrodes are used. In fact, the blue solution fades. Or you can say it turns colorless. Or you can say it turns pale blue. Reason? Well, the blue chemical is the copper 2. As you can see, over time, the concentration of this chemical is getting lower due to the reduction that happens. Next, describe what is seen at the anode when platinum electrodes are used. Now, when platinum electrodes are used, we do not care about the electrode. Instead, we focus on the electrolyte. So the anode, which is the positive terminal, will attract these 2 ions. from the electrolyte, and it will be our hydroxide that gets selectively discharged. Reason, hydroxide is easier to get discharged than sulfate. So when this chemical gets oxidized, it forms oxygen gas, water, as well as electrons. So from here, because oxygen gas is formed, we can see colorless bubbles. So at the anode, I've just written the equation. That's the equation. Hydroxide forms oxygen, 2 water, and 4 electrons. This is more towards memorization. Okay, that's the reaction that happens at the anode. Next, the electrolysis is repeated using copper electrodes. Now, copper electrodes are now active electrodes. That means they will start to affect the anode. So now, state whether the mass of the cathode increases, decreases, or remain the same when copper electrodes are used. Now, as we mentioned earlier, it doesn't affect the cathode. It only affects the anode. Therefore, we will still be having the same exact reaction where the mass will increase. Okay, however, the appearance of the electrolyte actually will then remain unchanged. Okay, remain unchanged. So why? Because instead of hydroxide getting discharged, as in this answer, a completely different reaction happens at the anode, in which it will be the copper anode itself that oxidizes and form back copper 2 ions, which then make sure that the copper 2 ion in a solution never runs out. We have one side where copper 2 is removed, however, copper 2 is supplied back by the anode. In fact, this is how copper electrolysis, electroplating is carried out. You can check about it on this topic, where the usage of active electrodes allow us to make sure that the solution never runs out of the desired metal ions. So since the concentration of copper 2 ions in the solution doesn't change, this solution remains the same color. Next question. Aluminium is extracted from its purified ore by electrolysis. Name is ore of aluminium, bauxite. So what is the substance added to this process to reduce the operating temperature? There will be cryolite. Now, explain why the anodes need to be continuously replaced during this process. Well, if you recall back on this whole process, right? This whole process, it is basically designed in a way where the anodes can be removed and then replaced and then put it back. Okay, if you look at the design, it's a bit weird that those are the anodes. Now, but why? Because in bauxite, it's aluminium oxide. And at the anode, the oxide ions from the aluminium oxide is getting oxidized to form oxygen gas. So it's because of the oxygen gas, okay, that is formed at the anode. It reacts with the anodes are actually made from graphite. Okay, graphite. So it reacts with the graphite anodes, and that forms carbon dioxide. Meaning the graphite anode and the oxygen react together and form carbon dioxide. Next question. Chromium is an element with atomic number 24 in the periodic table. The main ore of chromium is chromite, and chromite is having this formula, FeCr2O4. FeCr2O4 reacts with carbon. Complete the equation for this reaction. Now, we can see that our carbon is acting as a reducing agent here. Right, it's acting as a reducing agent here. And how many oxygen and carbon are there available? There's 4 carbon and 4 oxygen. So actually together they form 4 carbon monoxide, because that's the only explanation. Next, suggest one disadvantage of extracting chromium by reacting chromite with carbon. Well, you can see that the product has 2 metals, so not very good. So because we need to separate chromium from iron after the process. Next, chromium can be mixed with nickel and other elements to form stainless steel. Name the type of substance formed when the metal is mixed with other elements. That will be an alloy. Next, this chemical formula, this chemical is a compound containing chromium. The negative ion in this compound is Cr2O72-. State the sum of the oxidation numbers in the particular ion. The sum of oxidation number, we look at the charge. So that being -2. Now, the oxidation number of each oxygen in this particular ion is -2. Determine the oxidation number of each Cr2O72- ions. Show your working. Now, we can do it like this. Let the oxidation number of chromium be X. So we know that the total oxidation number, okay, or should I say sum of the oxidation number, is -2. And this -2 is created from the individual elements. So we have 2 chromium contributing their oxidation numbers, together with 7 oxides, okay, oxygen. So 7 oxygen, each of them contribute -2. So the equation will be 2x minus 14 equals to -2. So to solve for x, we simply just have to take -2 plus 14 divided by 2, which equates to +12/2, which equates to +6. As a matter of fact, this ion is, you may see it in your textbook. It's called a dichromic 6 ion. Dichromic 6 ion. So the 6 refers to the oxidation number of our chromium here being +6. Next, when this compound is heated, the following reaction occurs. Calculate the volume of nitrogen gas produced at room temperature and pressure in cubic centimeters when 1.26 grams of this particular compound is heated using the following steps. So first, we have to find out the number of moles of this compound. So we are given the mass. So to convert mass back to moles, we have to divide by molar mass. And luckily, we are given it here. Okay, 252. So 1.26 grams divided by 252 grams per mole, that we should give you a 0.005 moles. Now, then we have to determine the number of moles of N2 form. We have to refer to the chemical equation. So, given that from the equation, this compound produces N2 in a 1:1 ratio. 1:1. Okay, we read it from the coefficient. Therefore, if we take 0.05 mole of this compound, it will form the same mole of compound. 0.005, sorry, not compound, element. 0.005 N2. Lastly, how do we find volume of this chemical? Since this is a gas, therefore we just take 0.005 mole multiplied by its molar volume, which is 24 cubic decimeter per mole. That should give you 0.12 cubic decimeter, which equates to 120 cubic centimeter. Right? This one you just multiply by 1000 in order to get cubic centimeters. And the reason why we multiply 24 is because of a special property for gases, in case you don't know. Basically, gases for 1 mole, right? 1 mole of any gas occupies 24 cubic decimeters. So this particular amount, we just occupy 0.12 instead. Next question. Alkali metals are reactive elements. State the group number of alkali metals. Now, they are group 1. Now, identify the alkali metal which has the highest melting point. Well, going down group 1, actually melting point decreases. So the first alkali metal, which is lithium, has the highest melting point. Then, which one has the highest density? Now, density as you go down actually increases for group 1. So the one at the most bottom is francium. Which one has the lowest reactivity? Well, actually going down, reactivity increases. So it must be the first alkali metal, lithium. Which one will burn with a lilac flame? The signature color for potassium actually. Which element is found in the fertilizer to improve plant growth? Well, the 3 elements that we always mention is NPK, nitrogen, phosphorus, and potassium. So the answer here is potassium, which is a group 1 metal. Next, sodium sulfide is an ionic compound. Complete figure 5.1 to show the electronic configurations of the ions in sodium sulfide. Show the charges on the ions. Now, sodium electron arrangement based on the periodic table is 281, whereas sulfur is 286. To get a full outer shell, sodium will become sodium ion, which is 28, and our sulfur will become sulfide ion, which is 288. So, sulfur now, we have its original 6 electrons, but 2 coming from sodium. Okay, 2 coming from sodium, or is it better for me to, okay, let me put this here, this 1, 1. So it's 2 minus charge. For sodium, it will now only have 8 non-bonding electrons in its outer shell. So 1, 2, 3, 4, 5, 6, 7, 8. That will be the outer shell. And each of them have a positive 1 charge. So 1 mark for sodium, 1 mark for the plus and minus, 2 minus, and then 1 mark for our sulfur having 6 non-bonding and 2 coming from our sodium. Next, rubidium has 2 naturally occurring atoms, rubidium-85 and rubidium-87. State a term given to these naturally occurring atoms of rubidium. Now, isotopes. They are the same proton number but different nucleon number. Next, complete the table to show the number of protons, neutrons, and electrons in the atom of an ion of rubidium shown below. So, protons is based on atomic number, which you have to refer to the periodic table. For rubidium, the atomic number is 37, and it doesn't matter if it's an atom or ion. To find neutrons, well, the nucleon number is actually the sum of proton plus neutrons. So to find neutrons, we simply just have to take the nucleon number and minus the proton number. So the first one, you find it by taking 85 minus 37. This one will give you 48. And the second one will, you just take 87 minus 37, that gives you 40. Is it 40? Wait, hold up. No, 50. My bad. Now, to find electrons, basically like this. If it has no charge, the number of protons equals to the number of electrons. So 37. If it has a positive 1 charge, it means that there are more protons than electrons. So to create positive 1 charge, that means it only has 36 electrons. Next, the relative atomic mass of rubidium to 1 decimal place is 85.5. Determine the relative abundance of rubidium-85 in rubidium. Express your answer as a percentage. Well, since rubidium has 2 naturally occurring isotopes, our question here, we don't know how many percent of the rubidium is 85 and how many percent of the rubidium is 87. So what can we do about it? What we can do is knowing what relative atomic mass means. Relative atomic mass is actually the average mass of the isotopes. So what we can do is, right, we actually don't know what are the percentage abundance of these 2 isotopes. So we can actually let it be x, and this one will be 100 minus x. Why 100 minus x? Because total percentage abundance is 100. Therefore, if I draw maybe I draw a something like just a visual. Imagine, okay, this percentage is rubidium 85, and this particular percentage is rubidium 87. Okay, so we know the total is 100%, therefore this must be 100 minus x. So using this information, let's just calculate that. So it's just average formula, average mass formula. So we take 85 minus x, sorry, multiplied by x, plus 87 multiplied by 100 minus x over total abundance being 100. And that equates to 85.5. And we just have to solve for x. So let me adjust the equation a bit. So 8550 equals to negative 2x plus 8700. I'm trying to solve for x, by the way. So 2x is 8700 minus 8550. That gives you 150. X must be 75%. You can actually check your answers by substituting this value back. And you can test and see like 85 times 75 plus 87 times 25. Does it give you this answer? So the answer is 75%. Okay, moving on. Now, organic chemistry. Ethene is the first member of a family of similar compounds which contains the alkene functional group. State the term for a family of similar compounds which contain the same functional groups. Well, it will be homologous series. Homologous series are basically a family of similar compounds that have the same functional groups. Next, determine the difference in relative molecular mass between C2H4 and the next member in a family of these similar compounds. Well, the next member is actually C3H6. If you notice, you add by CH2. And what's the relative mass of CH2? Using periodic table, 12 plus 2, 14. Okay, in other words, as you go down, actually the mass increased by 14 for each succeeding member. Next, write the symbol equation for the complete combustion of C2H4. Now, complete combustion means react with oxygen, okay, in excess oxygen, such that it forms carbon dioxide. And then since there's hydrogen element, this also gets oxidized, which forms water. To balance the equation, it will be easier for us to look at carbon first. So 2 carbon dioxide form, and there's 4 hydrogen. So 2 water is formed. And based on calculation here, we have a total of 6 oxygen. So to do that, we need 3 oxygen gases. Next question. Ethene reacts with steam to form ethanol. This process happens in a closed system, and the reaction reaches an equilibrium. The conditions for this process are 300 degrees Celsius, 60 atm pressure, and using phosphoric acid as a catalyst. Complete the table to show the effect, if any, on the concentration of ethene when the following changes on the conditions are applied. So only use the words increases, decreases, or no change. Well, this year they asked for our concentration of reactants. So you have to be study careful for this question. Now, first, if we decrease temperature, equilibrium position will shift to the direction where it's exothermic. So let me write here, it will favor the exothermic reaction. And based on our equation here, the fall reaction has a negative enthalpy change, meaning the fall reaction is exothermic. Therefore, it will shift to the right, making less reactants. So this one will decrease. Okay, because they're asking us for reactants. Next, removing ethanol. So removing ethanol causes the system to favor the product side, favor the fall reaction. So also causes your reactants to decrease in concentration. When you increase pressure, it will favor the side with less gas molecules. So on the left, there's a total of 2 gases. We can read from the coefficient, 1 ethene, 1 steam. On the right, there's only 1 gas. Since it favors the side with less gas, that will be the forward reaction, which also causes your concentration of ethene to decrease as well. Lastly, change it to a more effective catalyst. Catalyst doesn't change the yield of the reactor or product in equilibrium, so no change happens. Next question. Explain in terms of collision theory why the rate of the flow reaction increases if the temperature increases. Now, so basically you have to say that the kinetic energy of the reactants increases, okay, of the reactant particles increases. So this causes an increase in the frequency of collisions, as well as successful collisions between the particles, right? Simultaneously, because particles have now more energy, there will be a greater fraction of particles possessing, okay, sufficient energy. And what does it mean by sufficient energy? Greater or equal to activation energy, okay, to react. Okay, so these 3 individually, they contribute to 1 point each. Next question. Compound B has the display formula shown in the figure. Deduce the molecular formula of compound B. Well, you just have to count. Okay, you just have to count. So here we see a total of 1, 2, 3, 4, 5 carbon atoms. We see a total of 1, 2, 3, 4, 5, 6 hydrogen atoms, and a total of 1, 2, 3, 4 oxygen atoms. So C5H6O4. Number 2, state why compound B is unsaturated. Now, so because, okay, it has carbon double bonds. Okay, carbon double bonds, right? Or you can say that it has a carbon bond that is not single, because saturated means all carbon bonds are single. Next, draw the structure of one repeat unit of the polymer form when compound B undergoes addition polymerization. Now, the word addition usually refers to only forms one product. And for IG syllabus, we only focus on alkenes. Alkenes undergo addition reaction. So the structural formula, the functional group of alkenes is carbon double bond. Okay, carbon double bond. That means this structure, okay, this structure will have this part, okay, this part open up, okay, open up. So it will open, turn into single, okay, single like this. Then the rest you just copy and paste, honestly. You just need to change this part to single, and then you just copy the rest, but make sure you read it correctly. So the first carbon is bonded to COOH and followed by a H. And the second carbon is bonded to a CH3 and bonded to a COOH. That's all. Okay, they didn't ask us to show all bonds, so I believe they are okay with you drawing like this because they give us such a small space. I think it should be fine if you draw it like this, unless the question asks you to show all bonds. Now, explain why 1 mole of compound B reacts with 2 moles of sodium hydroxide. Now, you must know that this is an alkali. That means it's the acidic part that reacts with the alkali. So you look at the diagram, what makes it acidic? Well, the carboxylic acid functional group. So you see, there are 2. So because it has 2 carboxylic acid functional groups. Okay, last question. Calculate the volume of this particular chemical that reacts with this particular amount of compound B. Now, so based on the previous information, we know that 0.1 mole of compound B will then react with 0.2 mole of NaOH. Okay, it's based on the previous information. It's a 1:2 ratio. All right. Therefore, you just take this information, 0.1 B will react with 0.2 mole of NaOH. So using this information, we can calculate the volume, which is by taking the we have the mole, we have the concentration, right? So we have the mole with concentration. So we can find out the volume by taking the mole divided by concentration. So the mole is 0.2, the concentration is 0.25. So as you can see, the units will cancel each other and we will get the volume. So using your calculator, you should get a 0.8 cubic decimeter, and you have to convert it to cubic centimeters, which is multiplied by 100, you get 800 cubic centimeters. And that's all for this paper. So if you're struggling in IGCSE Chemistry, you need our help for tutoring, or simply you want to have the lesson modules to help you to catch up with the topics you struggle, you can contact us via the website below. We offer IGCSE Chemistry tutoring as well as recorded modules to help you score better in the subject. So that's all for today's lesson, and I'll see you in the next video.